This is question 4 from one of the CCEA past papers. This is a practice paper, I believe, from September 2021, and it's to do with R, V and A. So there's a fair bit to this question. We're just kind of one part here, so let's take a wee look. So it's time t seconds. P is a vector displacement from a fixed origin as follows. R is quite often used instead of S, and hopefully we're familiar with S, V and A, and again we can take this in as our R, and you differentiate to get from one spot to the other, and you integrate then to get from there to there. So it says find the displacement vector. So this is our displacement vector of P from O, which that's what's given here, when it has a speed of 10. So what we're going to have to do here is we're going to have to differentiate this and set it equal to 10 to try and work out our speed. Remember, speed now isn't a vector, so we're going to have to use a bit of Pythagoras to work that out. Once we get our value for t, we'll substitute it in here. So first of all, as I say, v is in dr by dt. So differentiating this, then we're going to 3 times the 2/3 gives me 2 t squared I. Again, 3 over 2 times the 2 gives me 3t. That's j, because remember that minus 3 then disappears. So our velocity then is going to be that. So our speed then is going to be the magnitude of a velocity. So we're going to have to find the square root of 2t squared plus 3t all squared. If I start to tidy that up, squaring this obviously gives me 4t to the power of 4, and then that gives me a 9t squared, and it's the square root of that then, which equals then our 10. So I'm going to square both sides here and just kind of rearrange it a bit. So it's going to be 4t to the power of 4 plus 9t squared equal to 100. I hope you see what I've done there. I've kind of squared both sides to get my 100 there, and we end up with that. So this is one of these quartic equations, but it isn't as bad as it looks. It'll kind of act quite like a quadratic. And this one then factorizes. So it's going to be 4t squared plus 25. And then t squared minus 4. You can effectively, if you want, and you're not sure what I've done there, let your t squared just equal an x, and then solve that quadratic and kind of change it back in. But effectively works in like a quadratic, and we can just kind of factorize in like that. So this is going to give us 2 values then. So it either gives us t squared is equal to minus 25 over 4. Obviously that's no good to us. We can't take a square root of a minus number in this scenario, or we have a t squared equals 4, and so t equals minus 2 isn't going to be an option for us there, so we're going to take t equals 2. So that's the time when the speed is 10, so we need to work out then the displacement vector whenever t equals 2. So I'm just going to sub that into there. So I know r equals 2/3 t cubed I plus 3 over 2 t squared minus 3j, and that's in meters. So subbing in the number 2 then, t cubed is going to be 8 times by the 2, so that's 16 over 3i. And let me see what I have here. Subbing in the 2 here gives me a 4 times 12, so 6, take away 3j, and that's in meters.